Hi, I'm Chad. I'm an architect here at Pallantier, and one of my favorite things to do is talk to customers and prospective customers about some of their business problems and how we can solve them together. We've really been driving on boot camps, and the first question I get is, can you really build stuff in a few days in a boot camp that's valuable? The answer is absolutely. We're doing it time and time again, but instead of me talking about it, let's show you how we go do it. So, AI-driven tools for your enterprise data building with AIP. The topics we're going to cover today are RAG, Retrieval Augmented Generation, or OAG. We'll get into the definition of that in a minute. Building data tools for LLM. So the second question we probably get is that my data's not clean enough. It's all over the place. I don't have enough. Usually that's not true. We have the tools and it takes less data you need to actually really build some of this advanced AI kind of applications that you see. So we'll get through how we make sure we clean up and get your data healthy and keep it that way. And then data as code is our term for modern change management. So we treat your data just like code and use the same Git-based principles. And so that really helps us move quickly across your ecosystem. And then data security, that's really not only just about securing data for your users now, it's also how do I understand what LLMs have access to and how we look at that security profile. All right, AIP logic, that's our LLM-backed functions. And so we're going to build some LLM-backed functions today and use the data tools that we'll build and allow those LLMs to navigate the ontology of our business to be able to augment generation. So we'll build some RAG use cases. All right, let's dive right in. First, just want to give you kind of a quick frame of the ontology. If we take a look here, this is really the, semantic decision layer of your business, right? So if we think about it, this is the model about how you operate, all the decisions, actions, data, logic that make up your business. And this is that map, right? And so the importance of this is going to give us the ability to start to anchor AI in the truth of what's happening in your business. So we think of the ontology in three different things. First, it's data. So think of data sources. This allows us to really have that anchor of your knowledge base of what's going on in your business right now. And that reduces the risk of hallucinations and it creates that trust that we need because it's based on your data. All right, second thing, we'll go over real quick, logic. So this is the different ML models, optimizers that you have across your business. And so we can create deterministic tools using this that we can then give AI to use to navigate and do different optimizations. Third part, actions. So this is where I actually do something. I find some cool insights. I have a good forecast. That's great, but it doesn't matter until I've actually done something that adds value. So this is about how do we actually take these actions, register them back into different source systems and platforms. As we have some ways to orchestrate and do that and define what those actions look like. And we'll get to that probably in another video here. All right, north of the ontology, now that you have this digital twin of your business process, what do you want to go do with it? You start creating analytics, workflows to orchestrate these things, and then integrations and things to write stuff back. So you can create this entire ecosystem on top of the ontology. A lot of different stuff there, more than what we can cover today. But the ultimate goal is to drive action that adds real business value, right? Then on the top here, it's, okay, now how do we put AI in here to empower humans to do more? Really, that's the goal. So as we start to map all these out, AI is really an accelerant for humans to get more done. Cool. Let's go look at what we're going to build today. So Titan Control Tower. This Titan is our notional data company that we use. We manufacture surgical equipment, masks, respirators, syringes, that kind of stuff. We've got customers, distribution centers. I just got word that we had a fire at our Haynes Medical Distribution Center that we have a lot of our surgical masks at. So let's go take a look at that. Haynes, zoom in here. Let's see what the impact of how many customers and like kind of what type of customers we service out of this distribution center. So I can quickly see, I have different hospitals and medical centers. That's not gonna be great if they don't have surgical masks. So what are we gonna do about it? If we dive back into Haynes here, we're gonna pop out the copilot that we're gonna build today. So we have a copilot here, and this is our chain of thought reasoning. We're gonna put in our prompt of, hey, we had a fire. The facility that we think we're gonna cause shortages of surgical masks, like what should I do? So if we click this here, this is part of what we're going to build. So this is going to pass this prompt over to our LLM function that we'll build. And you can see here, it's now going to start to go do something. So you see the supply chain tool. It's doing entity extraction, finding out which DC is the Haynes facility. So it's a Haynes Medical Supplies is the actual name. So you can see it did that entity extraction, went and searched the ontology using a data tool. Then the second thing is, okay, now I need to find what's the finished good, and it's able to figure out the surgical mask, go find the right surgical mask in the ontology of my business, so that different product definition. And you can see here, this is actually pretty cool. This is why I love the chain of thought. It's actually, hey, I made a mistake. I wasn't sure exactly the right thing. And it's able to course correct, but I can see that as a user to start to build trust about what is it doing? How is it finding this different things? Awesome. Now it's going and finding all the different customer orders that I'm going to need to update. So I know I'm going to have to ship these customer orders so I don't short them from somewhere else, but where do I have inventory, right? So it's going to go find other warehouses that have the same inventory, that finished good, and it's going to tell me what the orders are that I need to go update, how much, and to what new distribution center. So you can see DC11 had enough inventory, and it's writing out all the different customer orders that I need to go update and by which quantity. So if I'm an analyst and I had this fire, this is pretty awesome. Within just a few minutes here, I'm able to actually go figure out what I should go do about this fire so that I don't short customers. Pretty awesome. All right, let's go build it. So this is going to be our checklist of things as we go build today, just to keep me honest and help you kind of follow along with what we're doing. So the first thing we're going to go look at is kind of the pipelining, data health components, and how we actually start to get the data in here and build these things. HyperAuto is our software-defined data integration. So when we talk about that, it means I'm going to take metadata about the different source systems, use our knowledge about that, and then actually automatically create these pipelines for you based on the metadata of your system. And then actually go all the way through creating those pipelines to usable objects. So you can kind of see here, this entire bounding box of things. It's going to do the syncs. It's going to create the pipelines all the way through to the ontology objects. Pretty slick. What does that actually look like? All right, so this is our data lineage tool. You can see I put this stuff in red here. That was the stuff we built last time. So that was the BigQuery to a virtual table to a trouble ticket. How does that hook into more of my business? Well, let's go take a look here. So how all this fits together, these are the ontology objects. This is a subset of our ontology objects, right? The nouns and verbs, but the ones that are kind of focused here for today. So I've got customers, they have finished goods. They make those finished goods at a production facility. They go to a distribution center that have delivery, right? So that's how my business works. We're going to need these different data elements to back our different LLM back functions to really drive the RAG type workflow. So that's the ontology, and the links across all those are all defined here as well, as you can see. And we'll be able to use those different data tools in our LLM functions. Next part, when we're talking about HyperAuto, how all that fits in. So you can see this finished goods ontology object is actually built out by this green. These green things are all HyperAuto. So all this was actually built and generated and maintained by HyperAuto for me. So if anyone knows SAP systems or has to work with them, there is a lot of tables, a lot of internal knowledge in SAP that's very hard to understand. It's, 4-letter German table names. It's very, very hard. You can spend a lot of time unwinding it. HyperAuto automatically does that in hours, maybe a day, but usually it's about hours where you can start to get going. And so you can see this ontology object of finished goods is backed by all of this that's managed by HyperAuto. So again, how do we move quickly? Hook up to your SAP system, turn HyperAuto, go. What does that look like? So if we come in here, this is the HyperAuto configuration. There's a couple different things. So if you know SAP, there's different modules, right? So if I want to look at my material management, okay, let's see, vendor, material, I really want to go material side, right? So if I want to look at and you look at, these are all the tables related to material. So anyone's not familiar with SAP, look at all this just to define material. So very complex, and like, how do they join? How do I have quality data, right? That's difficult. You can also take it from the workflow. I want to go do supply chain use case. So if you think about it from a use case, I want to go do supply chain. Here are the tables and data I need. We also have this. This is one of our AIP assist features. So I can type in a prompt. I already did this, so I understand the sources, quantity, and the current locations of my stock and transits. And it's going to go query the metadata of your SAP system and our knowledge about SAP and figure out what tables I need to go do based on the prompt I want. And the cool part is now I can sit in here and actually just say, well, yeah, I want all that. Put it in my shopping cart, go build me the pipeline. Yeah, I want it to clean everything up. So we're auto doing all of this for you. End result is a pipeline like this. And so you can see this pipeline is actually for material. If we zoom in a little bit, you can kind of see all these different material tables. it's cleaning up, transforming, generating everything here for you. And this is just a matter of a few clicks. And within a couple minutes, you have a pipeline that you can go deploy, run, and you've got this data that you can work with. So we talk about how we can move quickly. This is another key point about how we move so quickly. And just to call out, you can see this banner at the top. This is read-only mode because HyperAuto is actually managing this for me. So as we have updates, you can actually have HyperAuto update your pipeline with any logic, enhancements, performance tuning that we manage as part of that. That's pretty awesome. All right. So we talked about HyperAuto and how that works. Next up, data health. All right. So back to our lineage tool here. This is great because there's a lot of different perspectives here. We're just kind of mapping out and showing kind of what different components are. But this dropdown gives me a lot of different things around permissioning, projects, repositories, all sorts of stuff I can go look at here. But we're going to click on data health just to kind of give you this purview here. So when I think about that, how do I know everything's happening across my ecosystem? We've got HyperAuto building pipelines, but how do I know the data coming through it is healthy, right? We might have issues with our source system. There might be connectivity. There are lots of different stuff in these complex pipelines that can go wrong. So how do I make sure that I've got healthy data now that I got something cleaning it up? We have these different health checks. And so let's go take a look. So if you look here, for example, I can look at a data health check. This one's been failing. I went and created this one earlier, so we can go take a look. If we actually jump into this material table, this is what this data set looks like. I can also see here my health. And so I can have different health checks. So now I created this one just so we can kind of show this one says, hey, this should be updating every hour. It's been 17 hours since it's updated. And on average, like that's not great. Something's going on with this data sync or this pipeline. That's not great. Now this is a simple one just based on time latency, but you can see here there's a whole bunch of other checks that we can set up based on the time and propagation delays, sync freshness, the row counts. Hey, I had 50,000 rows. Now I've got 500. Maybe some join key got messed up. Or now all of a sudden I have 20,000. The job still succeeded, but I don't have all the data I needed, right? So it's hard to like catch different things. You can create these health checks across any of your ecosystem. And then once they fail, you can set up different kind of signal modes. So I can have the different severity of these issues. I can alert someone and wake someone up. I can just have it in their inbox the next morning based on how severe the different problems are. And so you can start to enter in all sorts of different checks and play around with this. You know, I want to have 2 standard deviations from the median. Like this would normally be really hard to have to go set all these different things up. This is just integrated into the platform as you go. And you can manage these like through the UI here, but you can also script these out to have kind of standard set of checks across your entire ecosystem. Really cool, really helpful. And the fact that I can just come in here and see like, oh, is this one failure? Like I got an alert for one failure, or is this like a whole chain of failures? And you can quickly go see that from this data lineage graph. What's going on. So like I have failures here that are probably causing some sort of failure here, right? Awesome that I can quickly just go see that. All right, back to our checklist here. So we talk about data health, data as code, modern change management. What does that mean? Let's go look. All right, so back to our lineage tool here. So if we want to go talk about data as code, modern change management, what does that really mean? It's probably a kind of a pseudo term for you, but we think about this, you can see across the platform as we go through these screens, there's all these different symbols for branching, right? So we can branch out and merge this. We can branch also data sets and code. So if we go into the material object here, again, we'll take a look at this. This is the one we had with health checks on. Well, let's say here, I can actually switch to different branches. Pretty cool. So what does that mean? Like branching my data? Well, yes. So if we see here, I can actually compare the master branch to another branch that we might have created. So now I can see the stats about it when they've been updated, columns, do I have different row counts, all sorts of stuff there. So you can start to see what's changing, or as I'm changing things, understanding what the diff is going to be, maybe what impact I'm going to have, right? So you can see it's not just I'm comparing code, I'm actually comparing 2 different data sets and looking at diff. I'm also comparing code that might have changed it. Oh, I have more rows over here because I removed some of the filters and I changed that. Okay, that makes sense, right? So now I can really start to look at this. So if I want to go create a pipeline, I can branch an entire pipeline that also branches the data like this. And so I can run in parallel without affecting the master branch and go do my analysis and then do a diff on the output and say, did this have the intended change I want? Did this code change do what I wanted to go do to fix or change something, right? Pretty cool. The other piece that I'm going to hone in here is we're going to go over to Contour, which is our kind of our data exploration tool. If you see here, as I kind of have this same material data set, I'm on the master branch right now, and so I could switch over to another branch, and we can just look at that. So if I'm doing analysis, so let's say I have an exploration kind of set up doing a bunch of analysis, and I wanted to then look at that analysis with my new branch, I can switch over to that other branch, and it recalculates everything here. Pretty darn cool. The other thing you're going to see here is the date. Well, what does that mean? So in here, I actually can time travel back. So let's go back to November. So you can see here, I can pick another day. We're going to go pick here, and let's look at November 10th. All right, so I'm actually time traveling back. So if you've ever tried to debug tough race conditions, like, hey, it was fine then, why is it not fine now? What's happening? I actually can time travel back in data sets and look at that analysis that way, or in my pipelines as well. So I can not only branch and look at data across these different branches, but I can look at it through different points in time across different branches, right? So if you've ever worked in this space, like, that is super powerful to be able to go move quickly and feel good about the quality of your data, because now I also can have multiple people working on multiple branches at the same time. Again, this is how we start to deliver in these boot camps really quickly. All right. Back to our checklist. So we talked about data as code. Next up, data security. All right, so real quick, we're going to show you this. This is OMA, our Ontology Manager application. This is where we define kind of all the different pieces and components of the ontology, including security. Just give you a quick tour. This is where we define the properties that can involve kind of, you think about those as, the columns and those definitions, but they can be richer, like unstructured data. They can be links to geospatial stuff. There's a lot of time series data can be flowing in here. A lot of different stuff we can get into. We also define the actions. So when we talked about actions, these are what actions can I take on a plant. In this example, I want to create a new support ticket, investigation order, right? So you can do these different things and they go right back to one of our different source systems. That's where we define these. Maybe in another video, we'll show how LLMs can leverage these actions to go do things. Pretty excited about that. The link types, again, when we talk about data tools and LLMs and kind of the RAG workflows, imagine now I have a manufacturing plant, but I have all this rich sets of links, and those things have links to other things, right? So it's really that graph across my business that now the LLMs can navigate, because that's all defined here in the ontology. We quickly go over properties. This is kind of where you would define the formatting, how mature is this column? Is it active? Is it experimental? Something I put in here. You can create different custom type classes, display things in certain units, all sorts of really fine-grained stuff you can define in here. Pretty rich. Right, security. Seeing about this, I can take the groups that I have and start to map those groups to either the kind of the object level. So I want to be able to see just manufacturing plant and I can see any of them, or I only want to see the manufacturing plant that I happen to own, for example, or I have purview over. So we can get down to instance level. So you can do that as like entity level, like row and column level in a traditional data warehouse. We can get down to that fine grain of access, mapping that back to the different groups. So pretty slick, but this is really the central place that we do that. And quickly we'll touch on this, data sources. So in the ontology, right, we're creating all these different structures. This is how we process that and make it available out to all the different applications. There's a lot of different capabilities, like we have time series data in this one. So time series from different plant sensors coming in. There's a lot of stuff you can see here we're not going to cover today. We'll jump down here, automation. So this is pretty cool. As new objects are created or new instances are created, let's say it was a sales order. I could have an automation when a sales order is created to go do XYZ set of actions. It could call an LLM function and go do some sort of categorization, right? All sorts of stuff, but those automations you can also start to define in here. And then lastly, just real quick, you can see the usage. So what does that all accumulate to is like, what is an ontology object? Well, let's just show you. So the ontology object here, this is it. So you can see it's rich. It's not just a tabular data set. I have these metrics that are actually rolled up from things that I'm linked to. So I have yield and production data from the production lines at this manufacturing plant, the Boston manufacturing plant in this case, that get rolled up to that level because of those links, and I can display them on the plant data, right? And so this is pretty slick. I have time series data coming in real time. I've got schematics I can put in here, geospatial information, events and times. So like this timeline is pretty slick. Lots of stuff here that you can bring in, and it's all based on all those links that you start to find on Ontology, right? This is much more realistic about what's happening in your business than an Excel spreadsheet or some sort of report like that, right? This is very much rich application of what your business is actually doing. All right, let's jump back. Data security, I think we covered that. Next up, this is the fun stuff. Let's stitch it all together, and we're actually going to go build piece by piece the LLM back function. Okay, let's build an AIP logic function here. So if we think about this, this is our LLM back function. How do we want to go put this logic together? This is very much like if I was training a new hire, right? I'm going to give it the steps. What data should it go access, right? So we're going to put all this together, essentially train, and through prompting, what we want this LLM logic function to go do. So first of all, we're going to have an input. That's our prompt. This is just string input. You could have also pass in objects or other things. So today we're just going to have a string prompt input. And the first block we're going to go create here is our LLM block to extract the finished good from the text and go look it up in our ontology, what the finished good is. So I know exactly the material, not just the name of it, the material I need so that I can navigate my ontology or my business, right? I need the material number. And so this is how we're going to go do that. So let's set that up first. So you can see I'm going to have it extract the finished goods from the prompt. It has access here to this object. So I explicitly gave it access to this object. You can pick a lot of different objects here or narrow it down. So again, this is an explicit access from an LLM to certain ontology objects that I'm giving it. But I also can give it access to certain properties. Not just from a security standpoint of, hey, I don't want to pass in PII information, but it's also from an LLM, they need to have some narrow focus. If you give it access to everything all over the place, you're going to have more hallucinations. You're going to have things that are not as grounded in truth. So if you know in this use case, I just need to go find the actual material ID inside my company based on the entity extract, let's just give it those things, right? So if we go do that, I'm going to take the output and actually have it go do output just this block here, and we'll run through. And so here it's going to show you the system prompt. You can actually see as we start to use these tools, you can see not only the system and task prompt was going to do in the chain of thought reasoning, you also can see to kind of debug how is it using these tools? How is it filtering? What is it doing, right? So now it found the actual material number is number 1 here in this use case in our notional data, and it got the surgical mask. So it extracted the name of an entity, searched for it in my ontology, and went and actually gave me that material ID. So now I can use that, right? So if we take that same kind of concept here and we go down to our next block, we're going to do the same thing for our distribution center. So let's go output just the distribution component. Real quick note. So like you can see here, I've got this just for using plant name. Again, keeping it focused, that reduces hallucinations, that keeps the consistency in the flow. You also can change different models. You can see here we have GPT-4 on our own private endpoint. You can pick other models that we have, or you can bring your own different endpoints, different configurations about the temperature controls around these different models. Lots of different stuff you can do in here that we're not going to get into today. So if we hit run on this one, we're going to get the distribution center entity extracted, go search in our ontology. Again, this is using data tools. So pretty cool how it did that. So now I have the finished good, the actual material number and the actual distribution center in my business in ontology. Now I need to go do something with it to respond to the fire. And so in this case, kind of the supply chain tool, I have a tool that allows me to reallocate things when stuff happens, right? This might be the supply chain, part of the supply chain copilot. Maybe this is one of many end tools that we build across a copilot. So this, we're going to be a supply chain helper agent that we're going to find new distribution center to supply finished goods from that has sufficient inventory of product. So you can think about this as an analyst job that they might go do. And as we go in here, we're going to switch this over so it stops warning me. I give it access to a lot more. So again, it's access to each of these objects, but each of these objects aren't just standing on their own, right? The power when we talk about ontology augmented generation is it's also the links, the actions, the functions, and other things. So in this case, it knows how all these objects fit together because again, we mapped it out here, right? So if you think about this, I have these complex relationships. Sometimes there's many to many. Sometimes I have to make multiple kind of hops to get where I need to. That's all mapped on the ontology and just native. As we're building this, as I give it access, it knows how to get between those objects and navigate the relationships. That's, again, power of the ontology here. We also give it access to the calculator tool because I'm asking it to potentially do some math of figuring out based on a customer order and sufficient inventory. It might need to do some math for us. LLM's notoriously not great at math, but giving it the calculator tool, now it can do that more reliably. Again, reducing hallucinations, grounding it in truth. All right, so the first thing, so now we're going to take all the customer orders. I want to take all the customer orders at this DC that we went and extracted and found. Then I'm going to get the, for the finished goods that I went and found, right? So I'm giving it the distribution center and the finished goods. Go find all the customer orders for that product at that DC because guess what? It went up in smoke. I'm not going to be able to ship them. I'm going to short customers. So now I want to make sure I find a new distribution center that has plenty of inventory. And in this use case, we're just going to go find the one that's got the most inventory that's sufficient and just go ship from there. Maybe in another video, we'll show how you can call some different models to figure out the best one or, the lowest cost option to adjust for this, right? Today, we're just going to have it find the most. Then I want it to tell me back, what are those customer orders, the order number, and what new distribution center I need to ship from. Tell me as an analyst so I can go make those updates for us. And it's going to output that to a string that we'll give back to the user in the chat window, right? So if we now go run this end to end, you'll see it's going to call all the different blocks. And so this is finding the distribution center. Cool. Got the Haynes Medical Supplies. Done. You got the actual number for it. Same thing on the finished goods here. Found the finished goods number. Cool. Now it's going down to this last block that we just looked at, and it's got a little more reasoning it's going to have to do. That's why you see it taking a second, because now I've given a lot more information and context. And you can see I can actually track token usage across this. So I used 2,433 tokens of my 8,000 that just the base GPT-4 model can use. So that's my kind of context window for each of these blocks. Now it's actually going and finding, like, it searched around, found the customer orders, and then it's finding a DC that's got enough inventory based on all those customer orders. And boom, look at that. I've got output of, like, here's the new distribution center, here's each one of the orders, how much, and I need to update all these to ship from DC11. Pretty slick. Very much analogous to how do I teach a new hire to go do a job? That's exactly kind of what I'm doing here. So let's go hit publish and take a look at that. So that's published, done. Let's go use it. So back to our application that we created. And so how we're going to go use this here. And we're going to hit submit. So this is actually, I call that LLM back function and go do its chain of thought reasoning that we were just looking through in the debugger. Again, this is pretty cool. Kind of called that out before, but this is very RAG, Retrieval Augmented Generation. So it's retrieving data from my ontology, the knowledge of my business. But when we talk about OAG, that's really the Ontology Augmented Generation. And that's where we start to dive into now, how do I use functions, right? The other piece of the ontology, to maybe have an optimizer that's going to help me pick the right DCs that are at the lowest cost, shortest route, best thing for the customer. And then also back to, like, action, right? So if we think about the action component of the ontology, don't just tell me what the orders are or tell me what the optimized orders are. Tell me, like, here's the approval. Should I go do this? Yes, right? And that's how we start to actually then take actions right back to the SA pieces, update the orders for me. You start to see how now AI plus humans, and this is how we're empowering humans through AI. Pretty cool. So now it's telling me exactly what I need to go do. In this case, maybe the next videos we'll start to go into those other pieces of OAG, right? All right, that's the content for today. I hope you enjoyed it. Stay tuned for some more. Bye.